The Air Force Laboratory Heritage at Kirtland Air Force Base had its beginnings in the Special Weapons Command established at Kirtland on December 1, 1949. The command's primary mission was testing of nuclear weapons. In 1952, the Air Force Special Weapons Center replaced the Special Weapons Command to be consistent with the Air Force's organizational structure that assigned science and technology activities to centers, which continued testing and expanded its responsibilities in research and development. With subsequent reorganization at Kirtland, the Air Force Special Weapons Laboratory in May 1963 was formed from the research and development functions of the Special Weapons Center. The Air Force Weapons Lab pursued an extensive agenda of technical programs to include nuclear weapon effects, directed energy, and space technologies. In 1982 at Kirtland, the Air Force Space Technology Center was established with 3 laboratories reporting to it: the Aeronautics Lab at Edwards Air Force Base, California, the Geophysics Lab at Hanscom Air Force Base, Massachusetts, and the Weapons Lab. By the late 1980s, the Air Force had 13 laboratories located throughout the U.S. On December 13, 1990, the 13 laboratories became 4 super laboratories, with one being the Phillips Laboratory located at Kirtland. A major change occurred in October 1997 when the 4 super laboratories were inactivated and replaced by a single lab, the Air Force Research Laboratory. On October 31, 1997, AFRL stood up 2 of its initial 9 directorates here at Kirtland: the Directed Energy Directorate and Space Vehicles Directorate. Throughout its heritage and lineage, AFRL's Directed Energy and Space Vehicles Directorates have contributed state-of-the-art technologies to the nation's defense. The coil laser, adaptive optics, the TACSAT-3 satellite, and the Angel satellite program are 4 of many technological advancements that were developed at these directorates and which transformed the DoD vision of warfighting systems. In the late 1970s, the Air Force Research Laboratory developed a new type of chemical laser, the chemical oxygen iodine laser, also known by its acronym, COIL. The COIL laser provided the Air Force with an unprecedented capability to engage distant targets at the speed of light. Over the next 25 years, COIL became the foundation of a wide variety of laser programs, including the Missile Defense Agency's airborne laser aircraft, which achieved a historic shoot-down of a boosting missile in 2010, and the Advanced Tactical Laser, which further verified COIL as a highly reliable and effective laser technology for attacking tactical targets. Since the 1980s, the United States Air Force has led the way in a revolutionary technology, the biggest breakthrough in astronomy in the past 400 years: adaptive optics. This creation minimizes the effects of atmospheric blurring and provides scientists using large ground-based telescopes clear and high-resolution images of objects in space, an ability we never dreamed possible only a few decades ago. The military aggressively pursued the development of adaptive optics for primarily obtaining images of man-made space objects for space situational awareness. Today, adaptive optics is installed on most large astronomical telescopes worldwide, and it provides the Air Force with situational awareness in an important Air Force domain: space. The 1990s brought forth a new type of satellite science: hyperspectral imaging. This research and development was led by the Air Force Research Laboratory Space Vehicles Directorate and Sensors Directorate, along with other DoD agencies, and led to the TACSAT-3 program in 2004. This innovation became an experimental tactical reconnaissance satellite with the main mission to detect and identify potential ground targets within a geographical area, and collect, process, and downlink an image in near real time to the warfighter. In May 2009, TACSAT-3 launched and proved to be one of the most successful small satellite demonstrations in the history of the United States Air Force. This demonstration showed that its images provided useful warnings and revealed ground intelligence about terrain characteristics and locations of interest, and thus proved it had a practical utility to the warfighter. In 2007, Angels, The Automated Navigation and Guidance Experiment for Local Space satellite program began at the Air Force Research Laboratory's Space Vehicles Directorate. This microsatellite was researched and developed to improve current methods of monitoring the space environment and fulfills a military operational need for a small, tactical, rapid, and low-cost satellite. When launched in July 2014, the satellite featured cutting-edge payload technology, including a space situational awareness sensor that detected, tracked, and identified high-value space assets and objects, a collision avoidance system that ensured the vehicle's safety, and a navigation system that only required one GPS satellite in view to maintain the vehicle's location and maneuver precisely. Its improvement of space-based optics, on-orbit maneuverability, rendezvous and proximity operations, and its autonomy and decision-making capability all make Angels a revolutionary AFRL program. These two directorates have and will continue to develop advanced technology that ensure the Air Force's leadership in directed energy and space capabilities.